This is a bottle of ferrofluid. A ferrofluid is an oil with iron particles in it, which means that if you bring a magnet close to it, this happens. When we move the magnet around, the black substance follows. But what if there was a way to control this movement without any human interaction?
Behind this glass tank, there are 252 electromagnets lined up in a grid. An electromagnet is only magnetic when you send a current through it, which means that they will not affect the ferrofluid unless we specifically tell them to.
In our spare time over the last 2 years, we've been trying to figure out a way to individually control a large quantity of electromagnets, because when you can do this, the ferrofluid comes to life. Although controlling a lot of electromagnets has its challenges, it's still probably one of the most straightforward aspects of our device. The most secretive process, where very little information has been shared openly online, is making a nice and clean ferrofluid container. Our solution was honestly as simple as just using saturated salt water to contain the ferrofluid, but that's not a perfect solution on the long term, as it'll make the ferrofluid clump together over time.
Solving this problem and making the perfect ferrofluid container has not been a goal of ours. We've wanted to focus on the electronics and the code, but we've been able to make a few well-functioning tanks and shared our entire process here on the YouTube channel.
In fact, we've made this entire project open source. Code, CAD files and PCB designs. The entire build is documented in our video, so it should all be very possible to replicate for eager makers. We really hope to inspire you to make something similar so we can be a larger group of people contributing towards simpler ferrofluid systems with more functionality.
That's why we were super excited to show off our display at Oslo Maker Festival back in October. We'll let the audience make their own animations, and this is some of what they came up with.
Our animations are drawn in a third-party program called Aseprite, which is free as long as you're able to compile the source code yourself. We then use a Python script to parse the files from Aseprite into a file format that we've invented ourselves. These animation files are read by the onboard Arduino-based microcontroller and displayed on the screen.
While the ferrofluid display is finished, what you're watching here is not actually the final result.
Well, I mean, this is fetch final, but we are already working on fetch final, and in the future we'll probably work on fetch final version 4, and who knows where that will stop.
We have big plans for upgrades in the future, so please consider this version 1. In version 2, we'll have a lot of the small quirks worked out, and all the bugs will become features. Nevertheless, this is a fully functional ferrofluid display, or ferrofluid clock, if you will.
We've noticed that a lot of you really don't want this to be anything more than a clock. In our minds though, a display is a lot more versatile, and a clock is just a special case display application.
Our plans forward includes adding modules such as joysticks, buttons, wireless communication, asynchronous animations, and a lot of other stuff. But one of the things we really want to implement is video games.
So let us know down in the comment section what kind of games you would like to see us play on this thing. But keep in mind that we have to bring ferrofluid up from the bottom. We can't just ignite the pixel out of nowhere. One game we think can be implemented is a multiplayer game like Tag. 2 players control a blob each, and the goal is to avoid the opponent for the longest amount of time. Generally, avoid the blob type games are most likely to work in our opinion.
Like we mentioned earlier, we really hope that our project can inspire a ferrofluid community by removing some of the barriers that make a ferrofluid project daunting. Let us know if you make something using parts of our design or code. One of our upcoming projects will be to create a smaller, cheaper, more DIY-friendly ferrofluid display that hopefully makes the entry barrier even lower.
Because ferrofluid is beautiful to watch, we'll also do some smaller, more artsy videos in the near future. However, the video timeline of this channel was recently turned upside down, as I was admitted to an insanely exciting internship program in Silicon Valley, meaning I'll be abroad for a couple of months starting in January 2020. The program is at NASA Ames Research Center, and I honestly can't contain my excitement. It kind of feels like going full circle as well, since ferrofluid was originally a 1960s NASA technology. What I'll work on over there is completely unrelated though, and whether or not I'll have time to make any videos while I'm there remains to be seen.
Anyways, there will come more videos, but as I'm sure you can understand, it's a bit hard to determine an exact schedule at this moment. Therefore, if you subscribe to our channel, be sure to hit that notification bell so you won't miss our next video.
But that's it for this time.
Happy procrastinating!